So now we are doing part D, which says that r of x is going to be equal to 1 over x squared, right? Now let's go for this. We are first, what is the first thing you do? I know you're a boss at this. First get r of x plus h, okay? You need it. So this is going to be 1 over, wherever there is x, put x plus h. So it's now x plus h all squared. Exactly what was happening to x is what should happen to x plus h. Like we saw in the last one that we had a 3x. It should change to be a 3 of x plus h, okay? Both of them now. Now this is what happens. So then we can now say that r prime of x is going to be equal to the limit as h goes towards 0 of r of x plus h minus r of x all over h, okay? This is going to be equal to the limit as h goes to 0 of what is r of x plus h? 1 over x plus h all squared minus r of x. What is r of x? 1 over x squared. And it's all over h. They're just making us practice limits. I mean, we've been doing limits. You see, this is important because now you are seeing more and more how limits are being used to do more things. We've done this type of limit, something similar to this in other questions. Little did we know that it was going to be leading to this, finding derivatives. You see? So now you are just solving limits. Now you have to solve them in a derivative. This is important. This is beautiful. Now let's do it. So this is going to be the limit as h goes to 0. What do we do here? Basically, we know that we can't put a 0 here. So yeah, we have to do something. First of all, we make these two denominators be 1. So how is that going to happen? We just make the two things multiply each other. So it's going to be now all over x squared multiplying x plus h all squared, right? And then what now happens is we then say this x plus h all squared into this denominator. Of course, it cancels with x plus h all squared. We remain with just an x squared, which multiplies 1 and is just an x squared. Then we say minus, this is an x squared. We put it into this big denominator. It cancels with the x squared, and we remain with x plus h all squared, which multiplies 1 to be just the x plus h all squared. And it's coming after the negative sign. Then we say this is all over h. Now, what did we say we do when you have two denominators like this? You combine them into 1. So it's going to be the limit as h goes to 0 of x squared minus x plus h all squared all over x squared h multiplying x plus h all squared. Okay, we bring this h to then join, okay, like that. That's just what happens. It's a tip you must know. How? Because look, if we had said, we can say that this is an h over 1, okay? Which when you inverse it, because remember you inverse to multiply, so we can still say it is x squared. Then we say times, it's now going to multiply the inverse of this, okay? This fraction, this first fraction should multiply the inverse of this guy, which is what is the inverse of h? It is 1 over h. So that's just what happens, and it becomes the limit as h goes to 0 of the top is going to be x squared minus x plus h all squared divided by, now it's x squared h, because this multiplies 1. When you multiply fractions, the top multiplies, the bottom multiplies. Becomes x squared h multiplying x plus h all squared. And we're getting the limit. So now what do we do when we have it like this? This is going to be the limit as h goes towards 0 of. Now let's simplify the top. Remember, we have to. The top is simplified, but leave the bottom like this for now. So it's going to be x. Remember, don't rush to simplify the denominator. Don't do that, okay? Mathematicians, no, please. So there's minus, then we square this bracket. So what are we going to get? Square x, you get x squared. Multiply them together. X times h is hx times 2. It is plus 2hx. Then you square the last thing, which is h squared, is plus h squared, like that. And it's all over x squared h multiplying x plus h all squared. Now, what are we going to get? This is going to be now the limit as h goes towards 0 of, here we have x squared, then this minus that's affecting the whole bracket, it's going to be minus x squared, then minus affects 2hx, is going to be minus 2hx, then minus affects h squared, is going to be minus h squared, all over, now it's going to be h squared h, then multiplying x plus h all squared. Now, what are we going to get now? Well, we are going to be having it equal to the limit as h goes towards 0 of x squared cancels with x squared. We remain with negative 2hx minus h squared all over x squared h, okay, x squared h multiplying x plus h all squared. Now, what we just don't want is this h, which is in the denominator, multiplying here. How are we going to read? Because we can't substitute 0 as long as it's there. Because if you put a 0 here, it makes everything 0 because it's multiplying everything. So it becomes now the limit as h goes to 0. We factor out h from the top. It becomes h. Here we remain with negative 2x, then minus an h. all over, here we still have x squared h multiplying x plus h all squared. Then here the h and the h will cancel, h into h, 1 into 1, it's 1. We'll remain with the limit as h goes to 0 of, now it's going to be negative 2x minus h all over. The denominator now will be x squared multiplying x plus h all squared, which now just becomes, here we can substitute 0 because it doesn't make the denominator 0. So wherever there is h, we are putting 0 because it's going towards 0. So it becomes minus 2x minus 0 all over x squared multiplying x plus 0. Okay, and we'll just remain with minus 2x minus 0 is just minus 2x all over x squared multiplying an x, which is just going to be negative, this is 2x, negative 2x all over x cubed, which if we do simplify it, it becomes x into x, 1 into x cubed, you get an x squared. So it becomes negative 2 over x squared, which we can put the negative outside of the fraction. It's still very fine. So it's negative 2 all over x squared. And that is what you can have here. All right. Wait, sorry. This squared is still there. So there was a squared here, which was here x plus 0, which is squared. So this should have been x to the 4, which now when we say this, it becomes x to the 3. So it's going to be negative 2 all over x to the 3, okay? Whew, this is going to be it, negative 2 over x cubed. All right, now what do? We have this r prime of x. It is going to be negative 2 over x cubed. Now we can find everything else. We can find our r prime of negative 1. This is going to be negative 2 all over negative 1 all cubed, which is going to be negative of 2 over negative 1, which is going to be 2. Okay, positive 2, because you have minus of minus 2, and this is just going to be positive 2. Then we can have now r prime of 1, which is going to be negative 2 over 1 cubed, which is going to be negative 2. Then we can have r prime of root 3. Okay, r prime of root 3, it is just going to be negative 2 over, remember it's x cubed, so it's going to be root 3 all cubed, which now becomes equal to negative 2 all over negative 2 all over, you can say the square root of 3 cubed. You can do that, which is going to be negative 2 over this becomes 3 by 3 is 9 by 3, 27. So it's negative 2 over 27 root of 27. This is what you have, okay? Negative 2 over 27, which if you want, you can actually say this is negative 2 all over the square root of 9 times 3. 27 is 9 times 3, right? Which is going to be negative 2 all over the square root of 9 times the square root of 3. You can separate if they are multiplying, which becomes negative 2 over square root of 9 is 3 times the square root of 3 is 3 root 3. This is what you have. It's negative 2 over 3 root 3. And this becomes your final solution, and you'll be done. Now we can go to part E. Goodbye for now.